Welcome back. In the first video of this two-part series, we looked at and I introduced the em4 remote and em4 alert programmable logic controllers from Crouzet that's supplied by RS Components and Allied Electronics. Apologize for calling it radio spares in the first video. Old habits die hard, and I actually grew up buying and using equipment that was purchased and procured from radio spares, as it was called back then. Used to enjoy getting the catalog every month. Anyway, I digress slightly. In the second part, I'd like to actually power up one of the units. So I'm going to power up the em4 remote, connect up a light sensor and a temperature sensor, and just have a very quick run through a demo program just to show you how easy it is to tweak a program to make it work, to show how easy it is just dragging and dropping some of the components onto the Design Studio and uploading it to the em4 remote unit. The program will also upload data logging information, alerts and events for monitoring up to the em4 remote website, so that you could use a browser of pretty much any kind to go up there and look at the data and perform some graphing, trend analysis and things like that, and even download the data logs that are put up to the website on a scheduled basis, which is also one of the features of the modules that you can drag onto the design screen. So anyway, without further ado, let's get into the second part of the video. It's a little bit longer than the first one, but it does go into some detail and discussions about how some of these modules work, and I also walk you through some of the software features, just talking a little bit about some of the very extensive range of controls that are available to you to drag onto the design page in use for constructing your applications. So anyway, let's get on with it. As you can see here, I've just got a basic configuration right now. I'm just using some clips to provide power to the unit, and I'll power it up in a moment. And I have a light sensor, which is the thicker of these two wires, that's connected to 1C, and I have the temperature sensor connected to input 1B on this. And all you need, as I said, I've just provided 24 volts to one end of the leads, and the other end go into the analog inputs of the unit, and it's as simple as that to hook things up. Now obviously, normally with a proper installation for either the home or anywhere else, because I've just got this on the bench to demonstrate it, you would normally have your external sensors coming into a properly mounted terminal strip on a termination point, and then you would run point-to-point wires from that strip, maybe inside a nice case, so that this would be DIN rail mounted or something like that, and you would have your 24 volt common. You would feed this with 24 volts, and then you would just need to bring in the individual sense lines into here without having to have flying leads or anything for the 24 volt supply. So this is only because I'm doing this for demonstration purposes. Now, the other unit that I haven't shown you yet that I've got is also this one. It's a standard expansion module, and what this does is it adds another additional set of analog inputs, or you can use them as DC inputs as well. There's 6 of them. All right, and the other nice thing about this one is that the analog outputs, which there's a number of analog outputs on the other side, they are mostly PWM, but it has 2 true analog outputs on it as well. You don't have to put any smoothing to get a nice control for some kind of power unit or anything like that. It actually outputs a nice true 0 to 10 volts analog output right here. The other ones, because these are solid state relays, they can drive up to half an amp load, just like the ones on the main unit down here, but they're also PWM analog outputs if you want them to be. But the last 2, as I said, these are actually true analog outputs, not PWM, so that adds to the flexibility. And that's one of the reasons I asked RS Components, when they were sending me this, to send me this expansion module, because this can add a lot of flexibility if you're doing power control and you want it a little bit better than PWM, maybe a little bit smoother control and things like that, a little bit more resolution. So it expands the capabilities. And the way you attach these to these units is they literally just plug onto the end of the unit. Let me just move across it a little bit. There's a little hatch on the side of these, and you just take the plate off right here, and then these units will just plug in like that. They just click into place, and that's pretty much it. You do have little tabs that come out on all of these units. You can use the screw mount to a panel, or they've all got the DIN rail mounting built as a built-in capability as well, of course. So that's pretty much the EMC remote, or actually it's for both of them, the EMC remote and the EMC alert. That's how you basically build this, and you can add one more expansion module onto this unit if you want to, and that's really the limit for these. The power supply isn't designed to go further than that, and I'm not sure what other limitations there might be to prevent you going further. But you know, if you really wanted to go anything bigger than that, you're probably going to want to start looking at a bigger programmable logic controller. But you know, with the 16 inputs already, and you're adding another 6 inputs, that's basically giving you 22 inputs, and then you've got your 10 outputs here, and you've got 6 outputs here. So you've got now 16 digital outputs, 4 of which are PWM, and the remaining ones are either an analog output or they're relay outputs. And you know, so that's going to cover most anything you would want to build for a typical small installation, whether it be industrial, commercial, or some kind of home automation. So let's power this thing up and see what there is from the display perspective. So that's the standard power up screen, and what I have right now is I've just got a very rudimentary program running that's reading the light sensor, which I have here. All right, and that's running and displaying its output on this right here. I've got a couple of things in the wrong place, looks like, in the where they're rolling around. This reading here is just a random number generator built into the program that I've just outputted onto the display, and I guess I positioned it in slightly the wrong place, so we'll fix that when we go in and have a look at the software. These other two are based on the analog circuitry, so I don't have anything hooked up on that at the moment. They're just sitting there not doing much, but they're just putting a value on the screen. So the light sensor here, anyway, going back to that, if I just basically put my finger over this, you can see that the reading goes down to almost 0. It's a bit of light going through my finger. If I cover it with something a bit bigger, you can see it goes down to 0 and all the way up to 15,000. But of course, as I said, it's reading in lux, and its primary range is 0 to 3,000 lux. The temperature sensor that I have here is, as I said, the standard thermistor kind with a 10 kilo ohm resistance. So again, it's displaying on this top screen here. It's reading 20.92 at the moment. I haven't got a decimal place in here. Again, when we go to the software, we'll clean this up a little bit as well. I wanted to show you how to use the software and how easy it is. I haven't had a lot of experience with it, and this has been very quick for me to get a simple application up and running. I've done a lot of industrial control programming in the past, just not with this specific software, and it did not take me very long to get this working. So I have temperature read. Now that I brought this up off the floor, it's starting to warm up a little bit, and if I put my hand on here, you'll see that the temperature now will start to rise here and come up. So it's 24 degrees, 25 degrees, slowly creeping up there. And if I go back to the light sensor module, I have this one with a trigger internally in the code that if I go above a 1000 count for the light, it'll actually turn a relay on, and then if it goes back below, it'll turn it back off again. So if I just put my hand over this, you'll well, actually you'll hear it. All right. Now, what will often happen with these two is if you come out of this display, you can see here, I'm just holding the button pressed. There's a little, if you like, call it a debug mode, if you like, that if you hold the button pressed here, it shows you all of the inputs and outputs on the unit. Right now we're looking at the base unit, not the analog expansion unit. And the two outputs right now, the temperature one and the light one, are both sitting with a dot on them, which means that they're logically a 0, I think. And when I cover them over, sorry, they're logically a 1, and when I cover them over, they're going to a 0. So you can see the C is coming on and off as I cover this. This is just letting me know that it's working. And at the bottom here, I've got 1, 2, it's actually normally 1, 2, 3, 4, 5, 6, 7, 8, 9, A for the outputs. And you can see here that number 4 is the one that I've got triggering when I go below that light level. Okay. The number 1 output is connected to the thermistor. Guess it helps if I don't let go of the button, and it'll turn on or off depending on the temperature setting that I've got. And I can't remember what I have in there right now, but we'll look at that in the software. So as I mentioned previously, the biggest difference between this unit, the EMC remote, and the EMC alert is that the alert is geared towards sending SMS and emails out to a user to alert them or inform them of changes in the environment that the PLC is sensing, whereas the remote is designed more towards interacting with an internet-based website where it will send its data up to be charted for doing trending, and so that you can download it and analyze the data remotely. And you can send pretty much any data that the PLC is collecting, whether it be binary data for switches, zeros and ones for instance, or analog data for, say, temperature, humidity, pressure, light in the case of what we were just looking at. And these will be sent up to the website for visualization on some kind of display, and we'll have a look at that in a moment. But the alert will send it straight to your cell phone. Now, both of them, though, still allows you to remotely interact with the application and turn devices on, turn outputs on and off, and adjust things like set points for thresholds for temperature or light or something else. So let's go and look at the software. One thing I haven't yet mentioned for the em4 remote is that the unit comes with a 1-year wireless SIM card already installed and ready to go. After that, you need to subscribe to the service with EMC to have it operating as a remote device. The alert does not come with one, and you would be required to purchase your own SIM card and install it into the device. The remote, because it's going to the website and it's interactive that way, it's not dependent on some other cell phone network. It works right out of the gate. You don't even have to configure the unit in order to get it up and running to the website. You just have to create your account on the website, register your device, and there's a number that comes with it that you use to uniquely identify it. And don't lose that, by the way. Very important to keep a hold of it. And basically you're up and running. So let's go look. So the em4 software is a standard install. It's a Windows-based application, and once you've installed it, it puts an icon on your desktop, and once you run the application, it'll pop up and present you with a screen where you can actually start writing your code. So we'll just quickly do a new application just so that I can show you. So when you first come in here, you pick the voltage that your unit is working on, how many IOs, the display unit, and the type. So what we've got here connected right now is the remote, so we select the remote and we'll tell it we've got the glossy black. I don't think it makes any difference as far as functionality whether it's black, white, or robust, but it allows you to narrow down the correct part number, which is here. You select that, then just go next. Now you have an option to actually add the extension units that we may have connected. So in our case we have an analog unit connected, so all you do is you go in here and we got the analog E10A unit, which is the glossy black one. And you've also, the other options here, by the way, are the discrete. They're all the E10A, so there's no digital extension units in this list. So we're going to pick the one we have here, which is the 6 discrete and analog. And you double click it, or you can click on add, and it will show you in the list. One of the things that I found when I was first playing with this, which threw me for a second till I realized that was me being silly, was that I was highlighting it and then just clicking next, but I wasn't clicking add and bringing it in here, and I was wondering why the PLC was giving me an error when I was trying to run the application, and basically it was because it was detecting hardware that it had not been configured to use. So make sure that you either double click it or you click the add once you've selected the right extension unit, and away you go. So we click next here, and now we get into the designer. Now what this actually does for you is all of these black spots that are down the sides here, all right, there's one down each side. These represent on the left the inputs to the unit, and on the right the outputs to the unit, and they're all marked with the exact same markings that are on the physical unit itself. And if we go down here, you'll see that they'll change in a moment here. For these last few on the left, we've got the E10A analog and digital inputs on the left, and on the right hand side here, if I go up a little bit, you'll see that we have the analog and digital outputs, and you can actually click on any of these to actually look at the capabilities of it. All right, it just tells you that's analog. If you hover over it, analog, PWM discrete output, PWM discrete. So even if you're not 100% sure which ones you're using, the tooltips that pop up will tell you exactly what you're trying to connect to. So this is the basic design tool that you have to create your applications for the em4 remote or the alert. It's exactly the same interface, and what I'll do in a moment is I'll connect the other one up and show you what the difference, what you see is the difference in the software. To actually design an application with this, you have a number of sets of tabs with different functional blocks that you can include in your design. The first one is input output, and what you have is things like digital inputs, voltage inputs. The voltage input is 0 to 10 volts typically, and you've got a current input, which is typically going to be your 4 to 20 milliamps. You then have things like XW in, and initially this is like, what is this? I don't recognize that. And what this is it allows you to configure set points, or remotely when you're talking to the unit, for either from the website or from your smart device. This allows you to receive that communications and provide set point or threshold values either in word format, which is the XW, or in binary format, which would be on and off, true, false, on the XB ins. We then have the digital output, a PWM output, an analog output, and then we have the equivalent XW out and XB out. These are the two that you would use to monitor what's going on with your application. So these have the ability to transmit their current state up to the website for monitoring. This is not the same as logging, it's actually monitoring, not logging. And if you have any triggers and alerts, they can also be set up in the same way. The control, which is the next tab, has things like, sorry, catching the wrong button with my tab. You've got timers, you've got mathematical functions, you have things like a tachometer if that's what you want to be doing in your application. You've got bistables, you've got a set reset block where you can have one input turn something on, a separate input turn something off, and it will be a latch that would flip-flop in between. There's a whole bunch of different things. A 1 second clock if you were having some kind of interval thing that had to occur in a circuit. Next tab is basically looking at things like displays. So this is HMI/COM. The displays that are on here are the one that's built into the em4, and when you drag these on the screen, it allows you to set up where on the screen you display things and how you want to show it. You can also have the buttons that are represented on the front panel of the unit that allows you to integrate those into some control mechanism for invoking some kind of function. Maybe you want to have an override on a light rather than the sensor, and you could just push a button on the front panel, or use the plus and minus to increment or decrement a set point as an example. And then at the end, what we have are a data logging component, and you would just drag this on the screen. This is the one that allows you to actually accumulate data over time and archive it up to the website so that you can trend it and various other things. And then the final one on the end here is an event. Now what this one does is allow you to basically configure, if for want of a better word, an alert that would be sent up. It's not the same as logging where you would be trending it, but it does keep an event history once the events are triggered. So for instance, if you go over a high threshold of a pressure in a control process, you could send an event like an alert up to the website that would then be visible to the user when they're browsing on the website for this device, and the user would be required to acknowledge that event before it would clear on the website. One of the very interesting tabs now is the application tab. This is where we have a number of effectively predefined sets of functionality. So we have things like a cam input, a cam block, a angular cam timer. It's just running through these. We have pump management, we have flow management. Flow management is a really interesting one. I used to work for British Gas a long time ago, and used to often work with flow control and measuring flow flowing through gas pipes. And what we used to use there were either venturi tubes or orifice plates. And if I drag this on the screen for a moment and then just double click it, you can see here that this is immediately coming up. This is actually the default one, is using a diaphragm, which is basically an orifice plate, which is what it's called in the gas industry. But it will support venturis, nozzles, pilot sensors, and annubar sensors right out of the box. And what this requires is you would have to have two pressure sensors in all cases, because you're measuring effectively the difference between two inputs in order to calculate the flow rates and things. And so these modules are built right in to the PLC for you to use. So it saves you a lot of time and complexity trying to figure out how to make these things work. The next one you've got is things like water level. We've got the different temperature sensors. Remember I showed you the thermistor that we were using. Let me just clear this out of the way for a moment. So you can pick down, the one we actually have is NTC2, and what this one is it's a, there's not really much you can configure here, but remember what I said, if you've got a longer lead length and you've got some slight offsets in the readings, well here you can just offset a tenths of a degree offset to compensate for maybe any probe inaccuracies or other interference that might be offsetting the reading. We've got three different types. You've got the NTC1, NTC2, and NTC3. They basically all function in exactly the same way. The difference is in the temperature range of the device that you've got connected, that's all. We then also have the lux meter, which is basically the light meter, which again is a standard 2-wire device that we plug in. I showed you that earlier. And this allows you to configure the device, and basically it converts the voltage input, the 0 to 10 volts, into something that's more related to lux. It knows about how the device behaves and its characteristics. Going down the line of the other ones in here that we have is we have a sunrise and sunset. This is a very useful little feature if you want to be able to automatically turn lights on and off that are not normally part of the external stimuli. You want to know that at a certain time of the day, just turn them on, and as simply as that. You're not waiting for a switch to be pressed. And what this unit is, it's a sunrise and sunset. You feed it the longitude, latitude, and time zone that you're in, and it'll actually calculate based on the system clock when the sunrise and sunset is in that location for that longitude and latitude, and it will drive its outputs based on that. It'll even tell you the sunrise time and sunset time, hours and minutes for each day as it progresses. It will adjust it accordingly based on the time of year and everything else. And it has an output to tell you that you're on twilight time. You've got a rising pulse, which means that the sun is rising, and you've got a falling, basically when the sun is falling. That you could feed into one of the set reset latches, for example, and then have that output driving a relay to turn a light on and off. We also have a follow the sun. So if you have a motorized platform that is going to track the sun, maybe a solar installation as an example, then there's a module built right into this for that. And again, you can have all of the data that this is collecting, how much power is coming off the solar panels and everything else, output to your smartphone, your smart device, or up to the website. So fully Internet of Things compatible and fully capable of allowing it to be monitored from anywhere in the world. So if this is monitoring a solar installation, it could be at the end of a very, very long roadway in the middle of a field, or up on the roof where maybe it's not easy to get at, but it can quite happily now interact with you without having to have physical wiring running all the way down. You just have to have power to it, cell phone access available to it, and away you go. Now some of the end ones here now that are built in here is things like swimming pool filtration, defrost alert, maybe if you've got some kind of refrigeration units and things like that. You've got a heat curve for controlling a heat system, and the very last one is a PID regulator. The proportional integral derivative 3-term controller is a built-in module here where you can set your 3 terms, you can have it set to automatic, and you would be able to control any process that requires 3-term control. So whether that be an industrial process for controlling the temperature of a furnace, or whether it be a speed controller or anything else that has to have this closed loop 3-term control, the module is built right in. So that's pretty awesome. We now have a number of basic programming things where we have default 1 and default 0, memory storage for 8 inputs and things like that, random number generator, clocks, status output, summertime inputs. We've got calculation on the calculation tab, a whole host of different predefined calculations, decimal to binary, binary to decimal, shift registers, Boolean logic, square root, sine, cosine, multiplication, division, addition, subtraction. We've got gain. So you can build up your own custom logic as well if you want, quite easily, by just dragging these modules onto the screen. We have our standard logic, which is AND gates, OR gates, NAND gates, NOR gates, XOR gates, etc., etc. And you can obviously build these up to some fairly complicated logic if you want. We have some special functions. I'm not going to go into the details of exactly what all of these are, but you've got resettable initial SFC steps going through here, divergence to OR with 2 SFS branches, convergence, divergence, wait steps. So all, very common multiplexers, etc., etc. And then you've got macros that you can create to do various things as well, and you can create your own macros. We have a whole bunch of user-defined tabs, so that if you create some specific functionality and you want to reduce it down to a single module to reuse in your programs, then you can do that as well. And that pretty much is it as far as a quick run through here. Now obviously I have the em4 remote connected up, and if I look in the communications, remember I mentioned that it already has cell phone communications built in, and if I go in here, what it does is the only thing this allows me to configure in here is the Modbus, which is the RS485, and I can set the baud rate of the communications up to 56K4, I believe, no, 57K6, sorry, 38K4 was the previous one, that was what I was thinking of. You can set up the slave ID of it, anything from 1 to 247, which is old standard RS485 and Modbus compatible addressing. 1-bit, 2 stop bits, even, odd parity, or no parity. And your transmission mode is either RTU or ASCII communications. Every one of these menus, by the way, when you look at what these are doing, have a integrated help button where you can bring up the standard help menu, and it will tell you all about the piece that you are currently looking at. So if I just bring this out for this particular communications, it tells us in this case for the online help, but we can expand it out and you can see all of the functional blocks are all described in here. Okay, and how to use the unit in the help file too. So it's all interactive online. You can print the PDFs, of course, which are also available online. But for the communications for this one, as I said, all you get to do is play with Modbus. Now if I just flip the type of my PLC here for a moment, instead of having the 2GC, if I pick the 2GS and now go into the communications, what you see now is I have GSM, GPRS available to me as an additional option. So the Modbus is still there for local communications, but now I have the GSM one, which allows me to put in a PIN code if I have one for the SIM card, the SMS server, a access port name, the APN, which is vendor specific. So here in North America where I live, it's Rogers Communications, so I'd put in the details for that, and then a login and password so that you can configure your communication system. And once you've done that, then you're able to configure phone numbers and various other things for alerts. So up the top on the menu, now that I've selected a different controller, is I have a directory menu here where I can actually put a list of contacts that the program can use, either with telephone numbers or with email addresses, and a name, so that now once if you configure some of these, then in your program as you go through, you can now configure it to send an email to somebody depending on what it is, and somewhere else with a different alert you could send an SMS alert to a different device to tell a repairman maybe to come out because a valve is stuck or a temperature has gone over a limit for more than a certain period of time and it needs to be looked at. So it's all very easily configured, very easy to use software. And I'm not trying to show you how to design PLC applications here. I just want to run through and show you some of the features that are available in the software and how easy it is to use. So the last thing I want to quickly show you is the application that I had running on this display. I just wanted to quickly load it up again, clean it up. So let's not save this, and I have it just called test1. We'll load that in. Okay, so this first bit is just a tachometer, so I'm just going to clear that off the screen just so that it was messing things up here. I just highlight those and delete them. So I have an input feeding sunrise sunset. We're going to look at the website in a moment and see what that does, and also at sunrise sunset times it will drive an output based on the set reset. But coming down here, what I've got connected up, remember I've already shown you on the inputs, is I've got a temperature sensor and I have a voltage input going through a lux meter, the NTC probe setting, and then I have a data logger here which is outputting to a website. But I also have the output of both of these connected to a display, which is actually being shown on the front panel of the unit. So if I just double click on the display, you can see here that it allows me to pick, see the red lines on this right now is the actual display that I've got for this particular one, and it allows me to position it anywhere on the screen. It's basically 4 lines by 18 characters, and I can position it anywhere I like. So I'm going to keep this one up the top left. It's for temperature. And what I hadn't done was set the divide by 200. So right now it's saying it's 2,470 degrees instead of 24 degrees. So let's just correct that one. The other display I had here, which was the BO3, that one is actually showing the lux meter output, and that's perfectly fine. But the B22 input, which is this one over here, remember it was actually overwrapping, and that's just the output of the number generator. So I just need to move that along one, and as you can see there, if I do that, it's wrapping over onto the next line. So I bring it across 2 places, it's no longer wrapping. So now we've got that one set up. I can just basically say OK to that, and that will have corrected that. And now I can go to the other display. Now of course I've done all of these. It's the same menu for all of the displays once you've got it in here. You've just got to use the drop down and pick what you're doing. And you can see this first one I've done now, by the way, it's put a decimal point in here to show me that I've actually configured it for a divide by 100, because it's put 2 of the digits to the right hand side. So let's just say OK to that. And I'm not going to go into, as I say, the whole flow of this. I will be doing a bunch of follow-up videos that will show you how to use the software and create an application. I just wanted to show you very quickly how easy it is to go in here and manipulate it. And one of the things you also notice on the right is different icons for different things. So you can actually, I put a little fan symbol here to represent trying to cool something down. It's connected to the temperature threshold. I've got a light bulb representing the fact that we are turning a light on and off because of the light level, which I had set to 1000 lux. So what we've got is we have one input here coming from the actual temperature probe, which feeds into this trigger. We have another input which is actually coming in from the XWin module, the little drag-on thing. Remember I mentioned that you can remotely adjust the set point, or you can set it up locally and manage it from here as well. So what I have here is I've got 2 outputs, one for the lux setting, which is set to 1000 at the moment, and the other one is for the temperature set point, which is set for 22 degrees. So right now it's reading 24. So what I'm going to do is increase this by maybe set it to 25. That way if I stick my finger on it, it will go up. Outputs degrees C, and it's got to divide by 100, so that your setting is 2500, but you're divided by 100, so it's actually 25.00. So we'll just say OK to that. And now the way you get this to upload to the unit is you simply click on controller and you say write to the controller. And I haven't set the COM port yet for it. Oh, I need to set the controller back to the right kind as well. Sorry, just give me a second. It will give me an error if I don't set the right kind for this. So it's a it's a EM remote. Glossy back. Next, still got that connected. Next, and we want to set the COM port for this. Configure connection and COM1 test. Okay, I just neglected to update the driver. I'd reinstalled my Surface with Windows 10, and hadn't put the USB driver in. It was still seeing it, but the driver to actually talk to it from the software wasn't there. So quick add and it's done. So just a quick test. That's quite happy. So now we can actually send the software up to the controller. Now I'm here. You just click write to controller, and you get a little warning that it's actually running at the moment, and do I want to turn it off? So we say yes. All right, that's stopped the controller running. You get a little status screen come up. Now I'm going to switch the camera to look at the actual controller so you can see what's happening there. There's really not too much to look at on the display here. So let's just look at the controller screen. All right, there's the controller. So it's actually in the stop mode now. So because it's here, what it does is it shows you the status of its inputs, but it's not running any application or anything. So for instance, you can see there that I cover the light sensor over and it's coming on and off. If the temperature probe, of course, is unless it went to basically 0, it's not going to change it to say a B instead of a dot. But basically that's its standby mode. Okay, so let's just now send this up to it. So I've clicked OK on that screen. It's loading any application specific functions. Now it's prompting me to say to upload, and it's one of the questions is after loading start the controller up again, because normally when you upload the program the default behavior is it waits for you to tell it to start running. So I'm saying yes, start running. I say OK, and it just prompts for a final with a final warning telling me that I'm going to erase my program. Do I want to continue? So I'm going to say yes, and away it goes. It's uploading right now. Any second now we should see the controller reboot, and it should change the display. And there we go. So now you can see what we have here is that's my lux meter right here. It's fluctuating around a little bit, of course, because it's picking up the light of my hand moving around and things. We have the temperature now that is reading correctly 26.5, and we have the random number generator just being displayed up in the top left corner and no longer wrapping around into here. So that's how easy it was to literally adjust the settings for this thing and get it working nicely. And if I actually find a something to cool down this probe with, maybe a bit of alcohol will do it. If I just grab this probe and try and just cool down the temperature sensor. I've just dipped it in the alcohol. That should cool it down. So 25, 24, 23. I think I set the set point to about 24, so if it gets down below that we should hit a relay click. Maybe there. Maybe not 24. The one you can hear clicking, by the way, is the lux meter. Let me just cover that over. There, it's 26 is where it clicked. See the lux meter now, I can just click that on and off. So there you have it. That's the em4 remote and the em4 alert. So the last thing I want to quickly show you is actually going onto the website and see what information comes up for the em4 remote when it's sending up to the web for logging and everything else, because that's what this thing has been doing for the last 24 hours, is just sending up information about every 30 seconds, temperature and light and things like that. So let's go see what it looks like. So what we're looking at right now is the em4 remote website. So this is https://web.em4-remote-plc.com, and I've signed in with my account, and you can see here that there's a cartography map showing a little pin right in the middle, probably based on Google Maps or something, and that's exactly basically where I live. I'm zoomed out a little bit, and once you register your PLC and you give it the GPS coordinates, then it'll actually pin you a map. So if you've got several of these, you can actually have them located quite nicely, see it on a map and see directly which one you want to work with. And what you can do is you hover over these, right click, click on it, and it will bring you up a bit of information. And if you click on the name, it'll actually take you to the GPS location that you've got, the product ID, but now you can actually go in here and do some management with it. So if I go into maintenance as an example, and send some commands to it. So I'm actually, I'm not, oh, I guess I technically am connected. I'm going to disconnect the USB connection right now just so that I'm not cheating. Alright, so I've disconnected the USB from the screen, and I'm able to actually send commands to the unit over the phone lines, over the wireless network. So I'm going to tell it to read any event data, and I'll send that command, and it's going to go and communicate with the PLC and bring back the data. Alright, so that's come back success. Now I'm just going to do a couple more while I'm at it. I'm going to read the data log just to get it up to date with the latest data log. So that's going to reach out, dial the device. It's actually happened quite quickly this time. Upload any data logs, and then the final one I want to upload is any monitoring information to get a current status. So we'll send that as well. Again, it's going to quickly go out over the phone network, connect to it, ask for the information, and bring it up. Now if we go into data on the menu and have a quick look, we'll pick the device and we'll tell it to give us a table. Right now the default one is the events. You can see here there's a whole bunch of events that have been occurring that I haven't acknowledged yet. And so what you would normally do is go in here and acknowledge it. It will then send it back to the device and acknowledge it. And look at what else we have here. So that was looking at events. So if we go to the monitoring, all right, so what we have here is basically, remember I showed you the little drag on the screen icons for XB out, XW out, XB in, and XW in. So this hasn't read the status of any of these things yet. But if I click on the breadboard and tell it to display, it's going to do a refresh, and now it's brought up what I have available to me. And as you can see here, for the XW out read, I've got the rise hour, rise minute, set hours, and set minute. These are the labels I gave to the sunrise sunset node that I dragged onto the screen, and it's telling me that my just trying to see whether this has got the right. Oh, I've got to refresh those, I think. Sorry, wrong one. So just wait for that to reach out and grab the values from the PLC. It's dialing it up and connecting to it to grab them. And as soon as it's got them, didn't get an answer from the device that time. Oh, we did, I guess. First one didn't. So it's telling me now that the sunrise is 9 hours and 29 minutes, and the set is 0 hours and 52 minutes. Well, there's something wrong with that, of course, because I know for a fact it's not that, and I know actually what the issue is. So if I actually go to the other side of this, which is the XW in read write words, and I get the values from here, this is going to read the other node that was on the screen that lets me do my set points. And I know what the value that's wrong because I kind of set that up for this demonstration, and that is my time zone. I set it to -5, but of course the value that it actually wants for the time zones for this is in minutes offset. So what that should be is -300. Now I don't have to go back to the PLC to correct this. I can just literally say -300 here, click on send, and that will actually then adjust that set point. Now it's done it. It'll adjust that set point now for the correct time zone. So if I go back over to the XW out and I tell it to refresh those now and get the proper sunrise and sunsets, there we go. So now it says it's 4:34 in the morning is sunrise, and basically 7:57 is the sunset, which I happen to know is actually correct for where I am. So you can see now, without even having to go to the PLC itself, without having to connect to it, I've actually been able to go over using it as a full Internet of Things enabled device and control the set points of one of its parameters. And this could be any set point you like that the device is capable of. You just have to hook it up to one of the XW outs or the XWin read-write word or bit nodes, and you can control it. My temperature set point right now is set for 25 degrees as an example, and I've got 22.2 reading on the display. So if I go in here and set this to be maybe say 20, what you should hear when I send it is you should probably hear the relay click once the set point becomes active and the comparator now decides that, oh, I'm above my set point, and it should turn on what it thinks will be the fan. So if I just type in 20 here, 0.00, and send that and change that set point, just heard the relay click there. That's how quickly you can adjust the settings. Alright, so that's pretty impressive. Now the last thing we haven't looked at right now is the data log. So let's quickly go into here. And again, I'll select the device. If you have a number of devices registered, of course, you'll have a list of them in here if they're under the same account. And I'm going to pick temperature and just say graph this. Alright, so there's the temperature variances. Of course, this is where I was playing around with it, putting it in a bit of alcohol and sticking my fingers on it and things like that. But all of the data points here for the last, since yesterday at about 6 p.m. all the way through till now, which is 6 p.m. again. So the last 24 hours is being shown right here on the graph at the moment. Anyway, you can graph it. You can also export the data. So you can do a CSV export. That's just automatically downloaded it right to my laptop here on the bottom left corner of the screen here. Or you have other menu options where you can download an image, a JPEG, a PDF, or an SVG to bring it down to your PC. And the other thing we've got in here is the light level, so let's just graph that one. It'll be a little different, probably jumping around everywhere. That's where we were playing around a few minutes ago with putting my hand over it and everything. And you can actually multi-select these as well if you want to. It doesn't really make sense here because the two values are so different. One of them is basically 0 to 15,000 lux, so to speak, and the other one is 0 to 20. So when you try and graph both of these, of course, it's not going to show properly because the lux one is going to completely dominate the temperature one. But you've got the option. So if you had 3 or 4 temperature settings, though, you could all graph them all together. So that's just back to the temperature one, and there you go. So nice and easy to use, and very simple. And of course, because it's on a website run by the Crouzet, the em4 is completely remote controllable from any device that happens to have a web browser. So I'm not able to show you the alert right now, but I have to get myself a SIM card which hasn't arrived yet from my local carrier. As soon as that does, then I'll actually put together another video showing you how to use the SMS alerting and emailing feature. But in the meantime, the last thing I wanted to show you, I can't hook it up yet to the PLCs to show you it operating, but is the Millennium Touch Crouzet MTP8/70 display unit. This is a completely touch-enabled display that allows you to interact with your PLCs, multiples of them, and pull information up onto the screen and be able to trend, graph, show you alerts, allow you to input different set points and all sorts of things that you would normally want to do with a programmable logic controller remotely, but have a local interactive workstation. And this device actually has Ethernet connectivity, RS485, RS232, USB. It runs on 24 volts. It's got a IP67 rated front panel screen, so if you have it mounted in a chassis where it's all sealed around the outside edge, then it can tolerate a certain amount of splashing and things like that. And it is, as I said, fully touch interactive. and the graphics, there's actually a complete set of design software for this, very similar to ones that I've reviewed in the past for other manufacturers, where you can actually have your own graphics and everything else and put them on the screens and set up your displays to be whatever you want. See, I've got a clock up here. I just closed that. I'm picking up data transfer. I can go to home, look at things like a data block, and do trending and all sorts of things like that. And all of this is fully configurable with the provided software that allows you to do pretty much whatever you want with this. It compiles and uploads to the screen, and once you have it up there, it will just run autonomously. But because it has an Ethernet port, you can remotely, just like the em4 remote, you can actually upload software to it from the remote locations and things. The difference is it's not connected via the phone, of course. It's connected via standard Ethernet. But if you put that into a network, then again, based on firewall rules and everything else, it is fully remotely accessible from pretty much anywhere in the world. You can put a password into it and everything, of course, to secure it, and it's an 800 by 480 display, so very high resolution, very capable of being a master controller for a multi PLC em4 network of devices. So the em4 remote and alert is what I've been talking about today, but there are up and coming devices, the em4 Ethernet and an em4 local, which doesn't have any remote connectivity, for installations where you just have it running as with a local controller, and maybe something like the display here is providing your remote connectivity, because the display even supports a VNC server, so that you could technically connect to it from any smart device anywhere else and actually visibly look at the display with, say, a tablet or something else while you're walking around a factory, or you know, if you're on a bus on the other side of the world and you're connecting via a phone system, it would all work equally well. So anyway, that's the last device I've got, and I will be doing some more posting and videos on it once I've got the connectivity sorted out, because the cables that came with it don't quite fit these devices I've got. They're actually designed for another controller, and I forgot to ask Radio Spares to send me them. So I'll be talking to them about getting some corrected cables very soon, and we'll have a look at that as well. But it is a very, very capable display, and all of these are available from Radio Spares or Allied Electronics for you to use. But if you're doing a installation where you want the reliability, you don't want to have to be designing and building all of your interfacing logic yourself. You want to be able to just screw this onto a wall or mount it into a DIN rail, purchase a few sensor probes like temperature, light, humidity, pressure, whatever, 4 to 20 milliamp, and just hook them in and go, and be able to have the outputs going to relays to turn on and off maybe a valve for flow, or a furnace for temperature, or something like that. Then this basically will work for you right out of the gate. And so even though it is more expensive than what some people would think with a Arduino or something like that, of course you're talking about a completely different market. And the nice thing with these, as I've said a few times through the video here, is that they're fully IoT, Internet of Things capable, because you've got the communications with a smart device with the em4 alert, and you've got the full integration with your remote central data collection site with the em4 remote going off to the website that we were having a look at just a moment ago, and you can download all of your data from there without any issues, and it's all secure through HTTPS and everything else. So yeah, that's pretty much the product. I really like it, and I look forward to doing a lot of work with it over the coming months to show you how to use it, and I'll hook up some of my other equipment that I have here, and maybe even look at it to control, maybe do some battery testing, things like that, some long-term battery discharge analysis and things, because between the analog inputs and the analog outputs, as well as the relay control, we should be able to set up some fairly complex, or certainly some long-running control applications that will allow us to evaluate its capabilities. But that's for another video, and but for now I just wanted to introduce this product. I've probably gone on a little bit longer than I intended to, but I hope you enjoyed that, and I hope you would consider the em4 remote and alert for your next Internet of Things industrial control application, because I think this is a very capable device, and I actually quite like it. It's built very, very nicely. It's works right out of the box. As I said, with the em4 remote, it comes with a SIM card already installed and a full 1-year subscription to the service, so you don't even have to pay for that until you're a year in. The em4 alert, you do have to get a SIM card, but it doesn't have to be an expensive one. For instance, here in Canada where I'm at, a local Rogers service would cost you about $10 a month just for SMS. That would give you a limited number of messages, but you don't really want to be having this thing connecting to the phone line all the time anyway. But that's the introduction over. As I said, keep an eye out for further posts on usability, having the RS485 hooked up, having the devices talking to each other. Hopefully very quickly I'll be able to get the connectivity for this display sorted out as well. And I look forward to investigating the capabilities of these devices even more. So thank you.